the summer meetings every year. I got valuable feedback on the work that eventually led to the Nobel Prize.
The year is 1930, and invitations are sent to leading economists around the world to attend a meeting at the Statler Hotel in Cleveland on December 29th at 8 p.m. Its agenda: the creation of an international society for the advancement of economic theory in its relation to statistics and mathematics, which at the time was revolutionary, and to support unification between theory and factual studies in economics and a constructive and rigorous way of thinking, similar to that which has come to dominate in the natural sciences. In other words,
promoting the use of economic theory to study real-world data, thus making economics much more useful in the real world.
They call this new society the Econometric Society. 16 economists attended that first meeting. Irving Fisher, the father of econometrics, was its first president. In 1933, it launched its first journal, Econometrica, now regarded as one of the leading journals in economics, receiving well over 1,000 submissions a year. In 2006, it launched Theoretical Economics, and in 2010, Quantitative Economics, and a growing monograph series.
Econometrica. It's really a journal that's known for publishing important research in mathematical economics, economic theory, empirical work, econometrics, that has a long-lasting impact.
When I was in the World Bank, I saw firsthand how ideas that were published in Econometrica many years ago ended up being influential in actual policy.
Today, the Econometric Society has more than 7,000 members in 85 countries. Here's just some of what it gets up to and why it matters.
What separates the Econometric Society from other learned societies is that it's a truly global organization.
The Society organises up to 10 international meetings and 6 schools annually, and once every 5 years, a World Congress.
The Australasian meetings always attract an excellent group of international scholars.
In Latin America, the Econometric Society has been crucial for the development of a community of economists working on issues of interest to the region.
And as a woman from China, I really benefit a lot from Econometric Society. But I think not just me personally, I think for all the women Chinese economists.
It's the only society that brings together scientific research in economics and econometrics from across the world.
The Society has always supported the careers of economists.
I published my PhD thesis, my very first paper in Econometrica. That puts one on the map.
Over the last 4 years, we've had a winter school at the Delhi School of Economics, which has been in collaboration with the Econometric Society.
Summer schools provide a great opportunity for young scholars to learn the latest techniques and also to interact with other young scholars in their area and senior researchers in their area.
It's the intersection of economics, statistics, mathematics, and it gives credence, it gives support, it gives recognition to those of us who do mathematical economics, theoretical economics.
The Econometric Society started with 29 fellows in 1933 and has since elected over 1,110 fellows, representing more than 30 countries.
It is a huge honor to be elected by one's peers in the society.
In the society and in the profession in general, I have always felt that I'm treated equally with everybody else, regardless of gender or regional origin.
The Society receives financial support from its members, as well as from sponsors. It completes all of its work on a small budget and relies on the tremendous support of host institutions and hundreds of academic volunteers from around the globe. So how has the Econometric Society fared in its mission? At the latest count, the Nobel Prize in Economics has been awarded 53 times to 89 laureates between 1969 and 2020. Of the Society's 1,121 fellows, 81 have won the Nobel Prize in Economics, representing 91% of all winners. 28 of those Nobel winners have been president of the Econometric Society.
I still find reading the journal and looking at the forthcoming articles as a really important way of seeing what long-lasting innovations are really happening in economics and econometrics.
It establishes such a constant scientific dialogue among people who are geographically very distant. I think that's very impressive.
I just feel part of a family that has been in existence for a long time, and it just brings me a lot of joy, just knowing that the giants were there before me, and I'm trying to step in their footsteps.
To find out more, become a member, or to support the Econometric Society, get in touch at econometricsociety.org.
No political, no nationalistic bias.
It's exceptionally important for young African scholars.
It's a leading body of scientific work and sponsoring economics.
Being elected a fellow of the society is a great honor.
When I was a junior faculty, I would go to the summer meetings every year. I got valuable feedback on the work that eventually led to the Nobel Prize.
The year is 1930, and invitations are sent to leading economists around the world to attend a meeting at the Statler Hotel in Cleveland on December 29th at 8 p.m. Its agenda: the creation of an international society for the advancement of economic theory in its relation to statistics and mathematics, which at the time was revolutionary, and to support unification between theory and factual studies in economics and a constructive and rigorous way of thinking, similar to that which has come to dominate in the natural sciences. In other words,
promoting the use of economic theory to study real-world data, thus making economics much more useful in the real world.
They call this new society the Econometric Society. 16 economists attended that first meeting. Irving Fisher, the father of econometrics, was its first president. In 1933, it launched its first journal, Econometrica, now regarded as one of the leading journals in economics, receiving well over 1,000 submissions a year. In 2006, it launched Theoretical Economics, and in 2010, Quantitative Economics, and a growing monograph series.
Econometrica. It's really a journal that's known for publishing important research in mathematical economics, economic theory, empirical work, econometrics, that has a long-lasting impact.
When I was in the World Bank, I saw firsthand how ideas that were published in Econometrica many years ago ended up being influential in actual policy.
Today, the Econometric Society has more than 7,000 members in 85 countries. Here's just some of what it gets up to and why it matters.
What separates the Econometric Society from other learned societies is that it's a truly global organization.
The Society organises up to 10 international meetings and 6 schools annually, and once every 5 years, a World Congress.
The Australasian meetings always attract an excellent group of international scholars.
In Latin America, the Econometric Society has been crucial for the development of a community of economists working on issues of interest to the region.
And as a woman from China, I really benefit a lot from Econometric Society. But I think not just me personally, I think for all the women Chinese economists.
It's the only society that brings together scientific research in economics and econometrics from across the world.
The Society has always supported the careers of economists.
I published my PhD thesis, my very first paper in Econometrica. That puts one on the map.
Over the last 4 years, we've had a winter school at the Delhi School of Economics, which has been in collaboration with the Econometric Society.
Summer schools provide a great opportunity for young scholars to learn the latest techniques and also to interact with other young scholars in their area and senior researchers in their area.
It's the intersection of economics, statistics, mathematics, and it gives credence, it gives support, it gives recognition to those of us who do mathematical economics, theoretical economics.
The Econometric Society started with 29 fellows in 1933 and has since elected over 1,110 fellows, representing more than 30 countries.
It is a huge honor to be elected by one's peers in the society.
In the society and in the professional in general, I have always felt that I'm treated equally with everybody else, regardless of gender or regional origin.
The Society receives financial support from its members, as well as from sponsors. It completes all of its work on a small budget and relies on the tremendous support of host institutions and hundreds of academic volunteers from around the globe. So how has the Econometric Society fared in its mission? At the latest count, the Nobel Prize in Economics has been awarded 53 times to 89 laureates between 1969 and 2020. Of the Society's 1,121 fellows, 81 have won the Nobel Prize in Economics, representing 91% of all winners. 28 of those Nobel winners have been president of the Econometric Society.
I still find reading the journal and looking at the forthcoming articles as a really important way of seeing what long-lasting innovations are really happening in economics and econometrics.
It establishes such a constant scientific dialogue among people who are geographically very distant. I think that's very impressive.
I just feel part of a family that has been in existence for a long time, and it just brings me a lot of joy, just knowing that the giants were there before me, and I'm trying to step in their footsteps.
To find out more, become a member, or to support the Econometric Society, get in touch at econometricsociety.org.
Good morning. Thank you for continuing this very nice conference. Now we have the BBVA lecture. We thank BBVA for this partnership that we are having, La CEA Lames conference. We expect to continue with this partnership in the following years. Now, as part of this sponsorship, the BBVA lecture, we have invited Horacio Atanasio. Horacio Atanasio is the Coles Professor of Economics at Yale University, a research fellow and one of the directors of the ESRC Center for the Macroeconomic Analysis of Public Policy at the Institute for Fiscal Studies. He's a research associate at the National Bureau of Economic Research, NBER, a senior fellow at the Bureau for Research and Economic Analysis of Development, and a research fellow at the Center for Economic and Policy Research. After obtaining the PhD at the London School of Economics, Horacio taught at Stanford University and the University of Bologna. He was also a national fellow at the Hoover Institution at Stanford and visiting professor at the University of Chicago. Before joining Yale, he was the Jeremy Bentham Professor of Economics at University College London. He has been managing editor of the Review of Economic Studies, the Journal of the European Economic Association, and Quantitative Economics. In 2016, he was awarded the Carlos Diaz Alejandro Prize by La CEA and the Klaus Jacobs Research Prize by the Jacob Foundation. In 2017, he was elected second vice president of the Econometric Society to serve as president in 2020. Horacio's research interests include household consumption, saving and labor supply behavior, risk sharing, evaluation and design of policies in developing countries, human capital accumulation in developing countries, early years interventions, microcredit, measurement tools in service. He has carried out evaluations of education financing and access programs, including large conditional cash transfer programs, the impact of a scholarship on school enrollment, and the effect of subjective expectations on the returns to education. Horacio's policy-focused work includes, in Mexico, serving on the advisory board of Progreso Oportunidades assessing the impact of a high school scholarship program for the Ministry of Education, and evaluating Jóvenes con Oportunidades. In Colombia, directing the evaluation of the Conditional Cash Transfer Program, a training program for unemployed youth, a workfare program, and several child stimulations programs. In India, the evaluation of large early childhood development intervention. In Ghana, the evaluation of Lively Minds, a child care intervention currently being scaled up. In Chile, assessing pension reforms and serving on the Comisión Asesora Presidencial sobre el Sistema de Pensiones. Let's welcome Horacio Atanasio.
All right. Okay. Are the slides on? No. Okay. It is a real pleasure to be here to another LACEA LAMES conference, and it's a great honor to be invited to give this BBVA lecture. You know, it's been a great 2 days. Hopefully the third one is going to be great as well. LACEA LAMES conferences have always been one of my favorite, and it's nice to be back in person after the Puebla meeting 3 years ago. So today I'm going to talk about subjective expectations. The issue of measurement has been very important for me in recent years. I've been thinking about the way we economists measure things and that we then use in econometric and empirical analysis. And I think we have been pretty shy for many years about measuring variables others than prices and real choices that people make and the like. And in particular, we have been shy about measuring things like subjective expectations. The consequence of that, there were good reasons to be shy, because it's not easy, and we'll see some of the difficulties here. But the consequence of that was that when we looked at models where expectations are important, we are forced to make some very arbitrary and sometimes very strong assumptions like rational expectations and the like. So this paper, which is in collaboration with Manolo Arellano and Britta Osberg and Sam Crossman at IFS, what we do in this paper, we take two subjective expectation data sets, or rather, two data sets that contain, in addition to regular variables like income and consumption and the like, also contains data on subjective expectations. One was collected in Colombia, and one we collected in India. So both data sets were run by us or by a subset of us, and were linked to the evaluation of some interventions. Pablo mentioned the evaluation of the conditional cash transfer in Colombia. That's where we collected this data at the time. And so in this paper, what we do is to show how we can use this data to estimate fairly common models that are used in the literature. Why expectations? Expectations are obviously extremely important and key to understanding many economic choices. And the reason is that most decisions involve uncertainty, and therefore people think about the future when making choices: when to buy a car, when to go to college, where to go to college, what kind of insurance arrangements you might take in the front of expectations. And so all these individual choices are driven by the way people take expectations and how they're formed. And as a consequence, they are important for policy interventions and for policy analysis. the expected value of certain variable is, in many situations, is not the only thing that matters. The entire distribution, distribution of future uncertain variables might be important. Think of uncertainty. Uncertainty is the variance or some sort of dispersion of future economic variables. And those are important determinants of consumption and saving decisions. There is entire literature devoted to precautionary savings, for instance. And this is key to the development of risk-sharing arrangements. Risk-sharing is particularly important because the way expectations are, because it depends on the degree of correlations among different individuals and the like. When you are in the business of, in the first part of my career, I worked a lot on consumption models, life cycle models, and there characterizing, to establish the properties of consumption, it is key to characterize the income process. And so that's important, and it's particularly important in developing countries where uncertainty and fluctuations in income can have dramatic consequences, being the mean level of income particularly low. Now, as I said, in the conventional approach in most of the literature has been to identify the stochastic processes, characterize the stochastic processes for income and other variables, is usually to rely on the dynamics of realized variables. So what is the income level for a number of individuals over time, often in combination with model choices. An alternative approach, which is the one we follow here, is to rely on subjective probabilistic expectation questions from survey. Now, these expectations were received by the profession with some skepticism for quite a bit of time, but now it's been almost 20 years, or probably about 10 years, where they become more and more popular and more used. The contribution of Chuck Mansky and his students have been very key in this respect. Chuck has been pushing the use of subjective expectations and proposing methods to use them, to collect them and to analyze this data quite a bit, and has been very important. And this has become also common in some data collected in developing countries. I have a paper in the American Economic Review where we look at some of the data available in developing countries. Unfortunately, probabilistic questions are still absent for most household surveys. Now, these are no new things. Subjective expectation data were present in the 60s in the US, in the NLS data. They're sometimes known as the Parnes data. And as I mentioned, Chuck Mansky has been pushing this agenda very much. And now, the Bank of Italy has been collecting data on subjective expectations for quite some time. Since 2013, the New York Fed has collected very rich and sophisticated data. I will refer to this at the end of the talk. And there are several other central banks, including the ECB, the Bank of Spain, and the Bank of Canada, that have been collecting similar data. And not only this data has been collected, but now they're put to use in not just in descriptive papers, but also in structural work. And this is an incomplete list of papers that have been doing this type of things using data from all sorts of the world. The last paper, that Faberman et al. 2022, is an econometric and uses the New York Fed data. Just an example. Now, this is the first motivation of this paper, this work that I'm presenting today. The second important motivation is the need to characterize flexible income processes. You know, for a long time, especially when studying the life cycle model, we have been using very simple, linear, typically log linear specification for individual income processes. And recently, there have been a number of important papers that have pointed out to the fact that there are important deviations from the linearity in real income process. An important paper that we use here is the Arellano, Blandel and Bonhomme in econometric again in 2017, where they specify a model that we'll look at later on, which is very nonlinear. And this can be extremely important to determine the consumption choices, these nonlinearities. The fact that, say, the persistence of income is not constant, but might vary across individuals and across realizations of current income. Analogously, the variability of income can vary depending on where in the range of things you are. So what we do is we estimate this flexible income process using two separate longitudinal survey data collected in India and in Colombia. At the beginning, I will show you we'll give you some information on how we collected this data. And this is important to characterize the econometric approach that we use to that. And so we use a method which is similar to the one proposed by Dominitz and Mansky in 1997. And in those surveys, we also have data on actual realized income. So we use a combination of that. And we'll have 2 waves of the Indian survey and 2 waves of the Colombian survey. So let me skip this. So the main contributions of these works are 3. The first one, we show how to identify the parameters of a standard dynamic model with or without fixed effect, using data on subjective expectations and current income. Notice we are looking at dynamic models. If you forget for a second the presence of a fixed effect, we'll show that we can identify the dynamics from a single cross-section. This is kind of obvious because the future is asked directly to the individuals through the subjective expectations. So that's what informs dynamics. It's a trivial point, but the reason I want to stress it here is because the whole identification of structural parameter, the approach to identifying the structural parameter takes a completely different approach. And I'll come back to this because I think that's an important methodological thing. After illustrating this methodological point, the second is that we show how to do it to estimate it very flexible nonlinear models. This is the Arellano, Blandel, and Bonhomme model. And we show how to do that. And then we show how to use that in practice, and that allows us to identify measures of subjective income risks that is completely different or might be distinguished by the variability over time. We can explicitly distinguish between uncertainty and variability. It could be that an income process is extremely variable, but maybe the economic agents know the determinations of this, so there might not be much uncertainty. And with the use of subjective data, we can distinguish that. So this is the outline. After this long introduction, this is the outline of my talk. I'll start with the data and expectation elicitation and talk about the data sources. So the first one is India. We use data that actually Britta collected almost on her own to evaluate a microfinance intervention in Andhra Pradesh in India. In that case, the population that we consider are relatively poor households. They depend on agriculture as their main source of income. They are farmers or agricultural laborers. You have two waves of data. The first was collected in 2008 and the second in 2009, and we have 720 households. And as I said, these are primarily agricultural occupations, very low education. 63% of our sample have no formal education. I stress this because, we'll ask probabilistic questions to these people. And I think that's feasible if you do it properly. You cannot ask them, what's your CDF? But you can design the questions in a way that can be answered. And I think people have in their head the probability. We have a paper with Britta where we show that descriptively that this data do make sense in a variety of dimensions. The second data set is from Colombia. And as I mentioned, the data was used to evaluate the conditional cash transfer program in Colombia called Familias en Acción. And so these are all households that are beneficiary or potential beneficiaries of that household. So the bottom 20% of the income distribution in Colombia, roughly, is spent. One is the indicator that in Colombia is used to target most welfare programs. So we used two waves of data. The first was collected in 2003, and the second one between 2005 and 2006. And we have 8,562 households. And this is a balanced sample across. This live in about 120 municipalities, small places in Colombia. Again, it's a relatively poor sample. 65% of the respondents are female. This is because of the way the program that we were evaluating. The mean average is 43 years. They have 3.5 years of schooling, so relatively low level of education. How do we elicit this data or information? So that's the way we do it. So in each wave of the survey, and this is done exactly the same way in India and in Colombia. In each wave of the survey, subjective expectations are elicited. And again, we don't elicit a point expectation. What do you expect your income is going to be next year? Rather, we try to get an idea of the entire distribution of future income. In this picture here, this is very similar to the approach used by Dominic Szymanski, as I mentioned. This picture, the blue things are answers given by the respondent. The red things are quantities computed by the interviewer. So let me tell you how this is done. The first thing that we ask, I don't have here the exact wording, but we ask the family, suppose that things next year go really, really well. Everything is rosy and at the top of your expectations. What is the maximum income that your household will be receiving under this scenario? It's a fairly long script. And then we say, so that's the max in blue there. And then we say, suppose that things are really bad. Everything is the worst possible thing. What is the minimum that your household is going to have? And so after quite a bit of piloting and changes to the way to the script to describe these situations, we see that these questions are pretty well understood. And so these two are in general, not just in Colombia, but in a variety of other contexts where we implemented this method that worked pretty well. This is important because we let the respondent anchor the range, the position of their income, and the variability of their income in a fairly simple way. So we don't impose ourselves. So what's the probability that your income is going to be more than $500,000? We let them do the anchoring of this. So once they give those two answers, the interviewer computes A, B, and C. So B is going to be the midpoint between max and min, and the A is going to be the midpoint between the min and B. And then they ask, what's the probability that your income is going to be larger than A? What's the probability that the income is going to be larger than B and larger than C? So these effectively give you 3 points of the CDF. It's the reverse of the CDF, but you get 3 points of the CDF that people have. That's the hardest part to ask, because these are probability questions, so you have to train them. So before asking these questions, we typically provide a number of examples. Say, what's the probability that tomorrow is going to rain? And then because we want to train them in how this thing changes, so after they answer the tomorrow rain question, what is the probability that next week is going to rain and that next month is going to rain? At that point, this probability should be increasing or not decreasing. If they make a mistake at that point, we correct them. And we say, look, if you say that it's 50% that it's going to rain tomorrow, cannot be that this 30% is going to be raining next week. So that's the warming up and the training that goes on. It takes a few minutes. Then we ask these questions. When we do that, we don't the interviewer cannot correct mistakes. So if they make mistakes, they will be in the data. So there will be some inconsistency in the data. But as I said, they work reasonably well. So that's how we collected the data, both in Colombia and in India. As I mentioned, the New York Fed does something similar, but it's not exactly the same. The anchoring is done on current income. So again, they don't impose any anchoring. They let them do it, but it's done on the current income. So they say, what's the probability that your income relative to what it is now will increase by 2%, 4%, 6%, etc. So it's a different approach. And so we went this particular way. So we then write down a model of the perceived income process, and then what we want to do is to link its parameter to the available data on subjective expectations. And so the general idea is that given the specification of our model, we want to fit the CDF implied by that specific model to the answers that we receive from the subjective expectations probability. So given that households have some process in their mind, the household subjective probability distribution or log future income is expressed in that particular fashion, where R is an arbitrary point. So that's the CDF for household I at time t, and that's and the I is the information available to that household at time t. Given this, effectively the answers to the questions that we have are given by those expressions. So the R, J, I, T are the J are the A, B, and C in the pictures. So those were the red dots, the red letters in my picture, and that's that. You can see that the approach here is different. If you think of the standard models that are used to analyze household income in panel data, we have a model, and then there is the income realization. There are some residuals to that, and that's what it is. Here, we are mapping not the actual realization, although those, as we'll see, might be in the information set available to agents, but we are mapping the CDF implied by the model to the answers given by that. Given the assumption we'll be making, is useful to use a logit transformation, as we'll see. So the L star there is the odds ratio that you can get from a logit model. That's the formula there. So then we model the log of the subjective cumulative odds, so that outcomes have in a limited range of variation, and the elicitation errors are probably plausibly additive. So we assume that what we observe is somehow affected by measurement error. So it's not really the subjective expectation, but it's that plus some error which is additive. So what we observe is a transformation of LJIT, which is the true LJIT plus measurement error. We do some, there is a little bit of bunching at 0 and 1, not a huge amount, and we don't want to throw away those data, so we use this Koch transform to avoid throwing away. That's not really an important point. That's what we do. If we don't do it and throw away, there are not very many 0 and 1s. So if you throw away those data, we get effectively the same results. So it's not particularly. We assume that the information available to individuals is Markovian, in the sense that the current values of relevant variables is what matters to predict the future. And the time various variables that we use to model this Markovian process are the current available income of the households at the time when the information is collected, plus a bunch of other variables which we call XIT, which could reflect the nature and sources of income. So you know how many people work currently, what kind of occupations they have, and things like that. So as for those are time variant characteristics. We consider the possibility of time invariant characteristics, but those will be absorbed by fixed effects. So we'll have models with fixed effect that they absorb all things that don't move over time. And these capture both the household level and the village level characteristics. So that's the form that our model takes. The L star is a function G of the particular point you consider, the RJIT, and the observable variables and the fixed effects. And for each household, notice that we have 3 observations, because the J is, these are the 3 red points, the probability that correspond to A, B, and C. So for each household, we have those three points. And G is a non-decreasing function in its first argument, which is R, is the A, B, and C. So now, how do we do this how do we put this structure in practice? So next point is we map models to subjective expectations data. And we start with the simplest model. It's useful, if nothing else, to illustrate some of the points we make. And so we start with a linear model with fixed effects. So that's the one. So this is household I at time t plus 1. Their income, that's the log of income, is dependent on the current income with a persistent parameter rho, a fixed effect alpha I. Some households are permanently richer or poorer than others, and some random term V, which is scaled with variability sigma. In this particular illustration, we assume that V is a logistic, and it's independent of Y and alpha. We can do it with a probit, how is maybe more common in the literature. We get very similar results. The logit is easier in this context because of the odds ratio stuff that gives linearity in a very natural way. as we can see here. So the corresponding conditional CDF is given by these expressions, and therefore once you apply the logic transformation, the model becomes fully linear, not in current income. It becomes linear in the answers that we get from the conditional probability, from subjective probability questions. And so we have that expression there. So the left-hand side are the P over 1 minus P that we get from the subjective expectation. The right-hand side are the R, the points of the subjective expectations that are the same across people. The way it's computed is the same across people. Then there is the current thing, there is a fixed effect, and there is a measurement error, the epsilon. So that's it. That's once you have this equation, you can apply standard methods to estimate it. And as I mentioned, you can do everything with probit. You get a similar kind of expressions if you assume normality rather than logistic. Notice that there is an, as I said, this is a linear panel model with fixed effect and strictly exogenous regressors. That's the first important difference. You don't need to use IV approaches. You can use within estimation, and you're not subject to what we call the nickel bias if you have very short t's. And that comes from the nature of the residual, from the nature of the data. When you do regress future income on current income and you have fixed effect, you have these biases that if your t dimension is short, will introduce severe biases. And that's one of the headaches that time panel people data have. We don't have that here. It's much more flexible in a way to estimate this. It's much simpler to estimate these models if your data are reliable. Now, having said that, the linearity still imposes a lot of structure on this problem. There is a very tight set of assumptions that the persistence and the variability are the two parameters that control everything. So the persistence is the same for everybody, is rho, and it's the same for any realization of income. So it's a very tight parameterization. And as we'll see, we relax some of these assumptions in what follows. Now, what's the difference between using this expectation data versus actual? And already hinted, there are some similarities. The sort of linear model that we ended up, they look similar in a way, but there are very profound differences between the two approaches. First of all, if you don't have fixed effects, you can estimate this dynamic model with one single cross-section. If you have a full model with fixed effect, you will need two, but still you can do it in a fairly simple way. And this is because with the subjective expectations, you effectively introduce the variation that you use to estimate, to identify these parameters. So the approach is different. And as I just mentioned, the estimation of subjective expectation model does not suffer from the nickel bias. And the reason for that is the outcomes are not future incomes, but the points of the CDF. And therefore, the error term does not contain future shocks, which in turn contain the fixed effect and induce the nickel bias. So that's all very nice. And three, this approach does not force individuals to have rational expectations. People can have the wrong type of expectations. They can be misperceptions. Now, testing whether the expectations are rational or not is a different problem, and it's not easy if you allow for aggregate shocks and the like. But in this approach, we don't have to assume rational expectations. And then we move on and try to look at more flexible models. And so that's the type of model. So again, we use the logistic transformation that we used before to get the L. So the left-hand side is, as before, is the log of odd ratios. So those are the answers for the pi's that we get. On the right-hand side, we allow this the effect of the R's and of the current income and of the fixed effect to be nonlinear. And so we use the betas will be splines in what we use, in what we do, and the psi is orthogonal polynomials. So you get more flexibility and a much richer model. Having said that, the model is much more complicated, and to estimate it, you have to be precise about what these functions, these splines and the orthogonal polynomials are. But once you specify that the methods are not too difficult. Once we have those estimates, it becomes a little bit harder to interpret the results. So what we do is we look at quantile-based measures of dispersion, skewness, and persistence. And so therefore we need to be able to calculate the implied quantiles from our conditional CDF. And so we define the quantile here, so the quantile tau in particular, and then from the model we get the logit of tau is going to be the G function. And the G function will depend on the specification we use. For instance, for the linear autoregressive model, the quantile is that expression, and as we saw, persistence is just parameter is the row there. And for more complex model, we can found a numerical solution to the specific quantiles. So for dispersion, we use, and we report numbers or estimates on the interquartile range. We usually look at the 75th and the 90th percentile of the distribution. So that's one. And for skew, I skipped the skewness, is the Bowley-Kelly measure. This is one of the many things I've been learning from Manolo, because I didn't know this, but that's a specific measure of skewness. For persistence, we used what ABB proposed in their econometrica paper. So it's the derivative of the quantile with respect to the current income. And so that could be different at different quantiles. It could be different in the distribution of fixed effects. So that's what we report. Okay, that's for the linear model, it's just a constant, is rho everywhere. Okay. Estimation approach, I already said that we use a piecewise linear spline specification, and with L knots, typically we do 0, 1, and 2 knots. I think the numbers that I will report will be with two knots in the thing. And then we have a Hermite polynomial for the psi function. Let me skip this. These are technicalities. There I have a couple of. This is actually quite interesting, but it would take me some time. The way you can introduce in this approach aggregate risk. Maybe getting the estimates from additional data, separate data. But A, we were not very successful in obtaining anything from the data we have on aggregate, and B, it would take me quite a bit of time to go through these slides. So let me skip the aggregate risks. And because I do want to get to the results that we get. I'll present first results for the linear model and then for the nonlinear extension. So this is a summary for the results on India. We have a model with and without fixed effects. And then when considering the fixed effect, we decompose the total variance of individual fixed effects into the variance across villages and within villages. We have about 40 villages in the Indian, 60 villages in the India data. In the Indian data, the measure of persistence rho is very close to unity, and is unaffected. This is the linear model, so it's just and is unaffected by the consideration of fixed effects, which suggests that heterogeneity in expectation is not strongly correlated with income. Including fixed effects does make a difference, so the total variability, a big chunk of it is accounted for by fixed effect, but the persistence in the India data is not affected by that. So that's the linear model for India. We have, very close to 1, very close to a random walk. You can see that sigma goes from 0.44 to 0.27 when introducing fixed effect, and that's the interquartile range, etc. And the sigma A, once we have the fixed effect, is the part that is accounted across villages and within villages, and sigma epsilon is the measurement error. All these standard errors are computed by Bootstrap here. For Colombia, things are quite a bit different. We do exactly the same exercise. So when we don't get fixed effect, again the rho is very close to 1. Once we introduce the fixed effect, it drops down dramatically. So quite a bit of the of the persistence seems to be driven by the presence of fixed effect. You can see it here. The first column has no fixed effect, so the coefficient is 1, and then it drops down to 0.47 once you introduce the fixed effect. One thing that I should have mentioned that I didn't is the questions for India and Colombia are a little bit different, in the sense that in the case of India, we ask them for the income next year. In the case of Colombia, we'll ask them the income next month. So it could be that these differences might be driven by the different horizon that is considered. Okay, so those are the data for Colombia. Now, all the specifications so far don't have any, that's what I mentioned. They don't have any excess. It's just income. So then the next step is extending these linear models to include observable variables like income sources, and we interact those variables with the current income. In the Indian data, the sources refer to the number of activities that the household gets income from, which could be farming, agriculture, labor, trade, etc. The persistence is not greatly affected by this. It's still 1 and 1. With or without fixed effect. The main difference is that persistence is higher for households with a sizable fraction of their income obtained from farming activities. So this is the results we get. Okay. And then for Colombia, sources mean number of household members with positive earnings from their weekly activity. And we have 15-20% that is 3 or more sources. So it is a relevant source of variation. And we observe that quite a bit of differences in persistence according to the number of sources of income. So the Colombian, the main difference, the way I see it, is that India is always one, the persistence is always one, regardless of what you do, or to a large extent. In the case of Colombia, the consideration fixed effect matters, and the introduction of these new variables matters quite a bit for persistence. So these are the results. This table has got fixed effect, and you can see that the rho is 0.4 for one sources and goes to 0.6 when you consider more sources. Now, the second step is going to nonlinear models. So that's the sort of model that I gave you before. In the India data, we find quite a bit of heteroscedasticity. The rich is probably the wrong word there, but the less poor individuals face less risk and have negative skewness. The persistence is non-linear in the sense that the position in the income distribution and size of shock matters for persistence. Remember, in the linear model, we got a 1 everywhere. Once you introduce nonlinearity, there are some deviations from the random walk that depends on where you are, both in terms of current realization and in terms of position in the distribution of fixed effect. And for the Indian data, the income sources do not matter much, and these nonlinearities are there regarding on whether you include these observables or not. Implication is that the linear model is very strongly rejected in the India data. Now you say, okay, these are the obsessions of econometricians. They want to reject simple models. I think it's much more than that, because the consideration of these different types of models and risk and persistence will have important implication for optimal savings, for insurance arrangements, for intra-household insurance, for the enforceability of insurance contracts and all that. So these are not just technical results. They are results that have important policy implications. So these are where they are, and you can see that if you focus for a second on, how do I do this? On the row, you can see that they vary in 2 dimensions. One is the current income realization, and one is the percentile in the fixed effect distribution. And you can see that, here, if you go bottom right is 0.8, bottom left is 0.5, top left is 1 is the random walk, top right is 1.6. So it goes all over the places, this parameter. It's a large variability. And the same holds for the interquartile for the interquartile measures, or 90-10 measures of variability. The richer individuals, they face less risk than the poor in general. For Colombia, introducing the observable does matter for deviation from nonlinearity. You still reject the model, but not as much as in India. So in Colombia, once you introduce these interactions, then you still have significant deviations from nonlinearity, but they're less important. And what we observe there is that high persistence is concentrated among households with 3 or more earners, with low income and negative shocks. And so there is some sort of, again, the implication for policy is a situation of persistence and misery on the left tail of the income distribution. So those are results for Colombia. what are the conclusions and the next steps? I would love to receive some questions at the end. I think in terms of what we learned is that in terms of econometrics, the sort of methodology and challenges that you face when using this subjective expectation data are very, very different. When you use actual data, you need a big T typically to estimate models with fixed effects. Here we don't. It's a different approach. It's also very attractive because you can get these measures of heteroscedasticity, skewness, and nonlinear persistence as perceived by the individuals in your sample rather than imposed. At least in one case, the standard linear model is strongly rejected, although in the other one is the treatment of fixed effects have very different implications for the two data sets. And so one conclusion is that it's not only current income, but also its nature and sources that matter for risk. In a different way in the two countries, but that's definitely true. It could be that, and as I said, these differences, we don't have an answer to that, but it could be that these differences are driven by the fact that the horizon is 1 month in the case and 12 months in the other case. When you have 12 months, you probably average out a bunch of shocks during the year. More generally, the questions that elicit to the probability distribution of future income give you a different approach to the identification of dynamic panel data model. This I mentioned. What are the next steps? I think this approach has also implication for more complex models. With Manolo and another set of co-authors, we are involved in a project that is trying to estimate earnings processes, but also which also incorporate discrete elements like unemployment risk, changes from job to job, changes of occupation. We are using the data that are collected by New York Fed. And there, once you start dealing with the selection issues implied by employment and changes in occupation, you can see that the identification that you can achieve is much richer here. Because when you do standard models, typically, it's the standard Heckman equation. When you have wages that you only observe for the currently unemployed, that's a selected sample. To identify non-parametrically that, you will need some exclusion restrictions. Here, with subjective data, you don't. And the reason you don't is because effectively you're playing God, and you present this respondent with all possible scenarios. And so you induce the variability that allows to model explicitly a selection into a change in job or into unemployment directly. So the identifications becomes much, much easier. It's a different issue. Again, you put on the left-hand side these CDFs. You don't put actual income realization. In this particular case, you put the CDFs under different scenarios. So if you keep the same, that's what they do at the Fed. If you keep the same job and work the same number of hours, what's the probability distribution of your future earning? What's the probability you receive a job offer? What's the probability you'll accept a job offer? What's the probability of distribution of offers that you receive? That's what they ask at the New York Fed, and it seems to be good data. We have started analyzing, and hopefully soon we'll have some results as well. So that's where we go, and I'll stop here if there are any questions. Where's Pablo?
on dimensions that I would have thought were at least partially captured by the fixed effect. So the biases are obviously not the same, and obviously the model is not the same, but still the fact that they are so, they don't change at all with the fixed effects I found surprising. And then the second question I had is, to what extent do you feel the differences in your two samples have to do with Colombia versus India, or rather with the agricultural sampling in one of the data sets? The other one, if I remember that correctly, seems to be more urban, a more urban group. And so I just wanted to pick your brain.
In terms of the effect of fixed effects and being different, there was a bit of a surprise. Among my econometrician friends, some were doing income processes. Some tend to think that fixed effects are not that important for generating persistence. Others think otherwise. So the answer of that is, the nature of the process is what's driving this thing. So the fact that in one country, once you introduce fixed effect, the measured persistence goes down dramatically, is an indication that the process is such that the fixed effect itself generates the observed persistence. In the other case, in the case of India, that was not the case. It's also, as you noticed, in the case of Colombia, the persistence is also driven down by the consideration of specific changeable variables like sources of income and the like. We don't have a very strong answer to that, but we feel that some of these differences are driven by the difference in horizon. So the fact that in Colombia is 1 month ahead, in India is 1 year ahead. This is data that we collected many years ago. We were thinking in those terms at the time. I don't know where they come from. In terms of it's true that there are very different societies. Colombia is a very specific sample, though. It's not representative of Colombia. These are all small towns. 63% is agriculture here. So yeah, it's probably even more important in India, but this is not Bogota. These are towns around 20,000, if not much smaller than, quite a bit smaller than that. Chico.
Thanks a lot, Horacio. That was really interesting. I was wondering, I guess using these subjective CDFs to estimate dynamic models, there's an underlying assumption that there aren't systematic biases, right, of the kinds that behavioral economists might say. So for example, if you had, systematic optimism or something like that, that would be a problem. And then it occurred to me that if you had a sufficiently long time series of realizations afterwards, you could use it to test or validate those hypotheses. Yeah. And in fact, those things might even vary across the distribution. You might have biases that are different across quantiles of the distribution. I don't know how long the time series would have to be, and I wonder if that's in your agenda or not.
Yeah, that's a very good question, a very important question. I mentioned it is very difficult to test rationality. I have, one which is not really an answer to your question is to say, look, if you want to put expectations in optimization models that people have in their heads, this is the right data to use because that's their perception, and their perception might be biased. I have another paper, completely different approach, looking at how people bought cars during the Great Recession. And there, because we don't have subjective expectation data, we use the car choices to reverse engineer perception of future income expectations. And we find that during the Great Recession, people had very dire expectations about the future, which might not have been completely justified. So I don't think, if we can move away from the assumption of rational expectations, it's a good thing if you do it in a consistent way. Now, how many waves do I need to test for rationality? And you're absolutely right. It could be that these biases or misperceptions of the future are different across the income distribution. That's completely plausible. How I go, you need quite a bit of data. One dimension, so there was something work we done in the first paper with Britta in 2016. We used variation across villages. They're a relatively isolated thing. So you might not have the ability to test the rationality of expectations about aggregate shocks across villages, but you can do that. And there we were kind of trying to validate the expectation data. People don't have crazy ideas. My main worry when we start working with this data is that, do this data make any sense? Or are we just analyzing noise? This was a valid worry that the profession at large had for many years. And I think it takes quite a bit of work in designing the questionnaires and stuff to make this plausible. We've been collecting this subjective expectations data in lots of different places. We've done it in Mongolia, in Tanzania, in Colombia, in India. One thing that I learned, there is no silver bullet. Every context needs a different approach we use a lot these visual aids. It could be a ruler where people indicate a probability on a ruler. That's what we use in these two. In Mongolia, that thing didn't work at all, so we had to do a different stuff. And so you might use the beans to distribute. So you have to do it. It's not easy, but I think it's a worthwhile effort to devise new methods. Any more?
Thank you for a great presentation. When you measure similar data in Progressa and you use the mean, max, and the middle point, and you're assuming a triangular distribution, I was wondering if you could do that with this data as well, and I was wondering if you compare the measurements using both approaches, what do you gain? Gathering 5 points of the distribution rather than 3?
Yeah, in the case of the Progressa was one of the first time we did it, and we only did it for a subsample. And as you pointed out, I'm amazed that you know that paper. But we divide the interval in 2, and we ask the probability of being below or above the midpoint. This is richer because it's done. An interesting thing we did in that work, we never wrote that up, but the results is there. So what we did, we randomized. So we did min-max, and then we compute the midpoint. And then we randomized half the sample. We asked what's the probability that is below the midpoint, and the other half we asked what's the probability is above the midpoint. And then we test the hypothesis that the two sum up to 1, which is an indirect test of the consistency of these answers, and they do. Again, we never wrote up the paper. But they do. Okay.
Okay. Thank you very much, Horacio. We have to make a stop here, just a 5-minute stop, in order to start the keynote lectures. Thank you.